Hello, in this video we are continuing our discussion of section 7.3 on the shell method. Now we are working through our example where we have a region in the first quadrant bounded by the graph of y equals the square root of x minus 2 and the line y equals 2. Let me go ahead and provide a label for that here. Y equals 2. These two curves intersect at the point 2, 6, and we're bounded by the coordinate axes because it says the region in the first quadrant. Now in part A, we revolved around the x-axis, or sorry, part 1. But for part 2 now, we are going to revolve around the line y equals -2. So that means that we're taking this shaded region and we're going to rotate it around the line y equals -2. So notice we now have a gap between our region and our axis of revolution. If we were using the disk washer method in the previous section, then we would have to account for that gap by having an inner radius and an outer radius. But in this case, it doesn't affect the shell method quite as much. So for the shell method, we draw a line segment parallel to our axis of revolution. So this means we're going to have that little line segment. Then this distance is the shell height. And the shell radius is the distance from that line to our axis of revolution. So for part 2 here, our shell height, notice this is the same sort of line segment that we had in part 1, which means the shell height is going to be exactly the same. It's the distance from the curve y equals the square root of x minus 2 to the y-axis, which is x equaling 0. And since we're still going the same direction here, we still need to put everything in terms of y. So solving our curve for x, we get x is equal to y squared plus 2. The shell height is going to be the same as part 1, so that ends up being just y squared plus 2. The bounds of integration also end up being the same because the bounds of integration only depend on the shaded region. The shaded region hasn't changed any, and we're still integrating with respect to y. So that means that our bounds are from y equals 0 to y equals 2. And last, we need to find our shell radius. Now this is where we get something different because the shell radius is always the distance from our little line segment to the axis of revolution. So if the axis of revolution changes, then the shell radius will change. Now we already know that the distance from our little line segment to the x-axis is the same thing as y. We also know that the distance from the x-axis to this line y equals -2 is a distance of 2. So that means that the total distance will be equal to y plus 2. And that total distance is what our shell radius is. So in this case, it's y plus 2. So this then means that our volume is going to be the integral from 0 to 2, since those are our bounds of integration, 2 pi times our radius, which is y plus 2, times our height, which is y squared plus 2, and dy. And there is our final answer for part 2. Notice the only thing that changed here, when we changed our axis of revolution, the only thing that changed was our shell radius. Everything else is only dependent on the region that's being rotated for the bounds, or for the height, it really just has to do with, yes, the region, but also what direction we're talking about. Since we're still talking about the same direction that we had in part 1, then that's the same. So changing the axis of revolution to a different value but in the same direction is only going to affect the shell radius for the shell method. Disk washer method gets changed quite drastically, but only the shell radius gets changed in the shell method.